how to get these inverses. Now once you have the inverse, it's very useful. Here's why. Let's say I have a 2 by 2 system of equations, or bigger, but I'll just use 2 by 2 as an example. One thing I can do with this equation is turn it into both sides into matrices. Each of these is a 2 by 1 matrix. Yesterday in the lesson I mentioned that we can take a matrix like this and rewrite it, sort of split it up. We did it by multiplying, but you can verify that x plus 2y, 3x plus 4y is what you would get if you multiplied together the matrix 1, 2, 3, 4 by the matrix xy. Now this looks a lot like something like, 5x equals 15. Now 5x equals, meaning that I have a number, a variable, a number. Here I have sort of a matrix, a variable, another matrix. Now we know to divide both sides by 5, but let's say there's no division, there's only multiplication. Well then, we multiply both sides by the inverse, multiplicative inverse of 5. And I get x equals, I get 1x equals 3, or x equals 3, because 1 times x is x. Well, the same thing actually is going to happen with matrices. If I knew how to find the inverse of 1, 2, 3, 4, which we've established now was minus 2, 1, 3 halves, minus 1 half, I can put that on both sides of this equation, minus 2, 1, 3 halves, minus 1 half. I could put it on the left side of this matrix also, minus 2, 1, 3 halves, minus 1 half. Just like this 5 and this 1/5 sort of cancel out, become the number 1. In this case, the inverse times, when you multiply the inverse by the matrix that is the inverse of, becomes the identity. And the identity times xy is just xy. So really the question is, what is the product of minus 2, 1, 3 halves, minus 1 half times 5, 11? And I could actually do that by making the matrix 5, 11. Oops. Second matrix, edit, number 2. Make it a 2 by 1 matrix. Make the numbers 5 and 11. That's called matrix B. And what I'm basically doing is I'm multiplying, if I were to call this matrix A and this matrix B, which it is, I'm basically multiplying inverse of A times B. So if I come over to my calculator here and I say second matrix A inverse of A times second matrix B, it will multiply them for me. I get the answer 1, 2, 1, 2. Means x equals 1, y equals 2. Now this is a pretty involved way of answering a fairly simple question, but you'll see that if we have to do many questions that have the same left-hand side but different things on the right, it might be useful to do this method, because once I've worked out the inverse, I could use it over and over really quickly. And so there are situations where this method is going to be pretty useful. Now, still haven't gotten into how do you actually find the inverse of a matrix. It's a somewhat lengthy process, but it's always the same process. So here's the way it works. This is one process of finding the inverse by hand. First thing I just want you to notice is that if I had the number 5, I put a line here and I put the number 1, what I need to do to turn 5 into the number 1 is multiply it by 1/5. If I do that, to both of these things, the 5 turns into the 1, and the 1 turns into the multiplicative inverse. So the thing you do to turn a number into the multiplicative identity would turn the identity into the number's inverse. That's the idea. And the same thing happens with matrices. What we do is we write our 2 by 2 matrix that we wish to find the inverse of, and we put the identity matrix next to it. Now, there's a 4-step process. I'm going to turn this into a 1, which it is already. Then I'm going to turn this into a 0, which it will be. Then I'm going to turn this thing into a 1. Then I'm going to turn that thing into a 0. It's going to be a 4-step process using row operations. As a result of doing these 4 steps, these 4 numbers here are going to change also, and what they change into will be the inverse. So good news is that this 4-step process, which is always the same, because this is a 1 already, we don't have to do that step. But we do need to make this 3 into a 0, which I can do by doing minus 3 row 1 plus row 2. In doing so, the first row does not change, but the entire bottom row changes. Minus 3 times 1 is minus 3 plus 3 is 0. You don't need to write down all the stuff. Minus 3 times 2 is minus 6 plus 4 is minus 2. Minus 3 times 1 is minus 3 plus 0 is minus 3. Minus 3 times 0 is 0 plus 1 is 1. And halfway through my process, I have a 1 and a 0 there. Now we want to change this minus 2 into a 1, which is easy because all I have to do is take row 2 and multiply by negative 1/2. So row 1 does not change, but row 2 becomes 0, 1, 3 over 2, minus 1/2. And finally, to make this 2 into a 0, I'll say negative 2 row 2 plus row 1 into row 1. In doing so, row 2 stays as that. Put row 1, 0 times minus 2 plus 1 is still 1. 0 times 1 is minus 2 plus 2 is 0, like I expected. Minus 2 times 3/2 is minus 3 plus 1 is negative 2. And minus 2 times 1, minus 2 times minus 1/2 is 1. Added to 0 is 1. And that's the answer. This here is the inverse. So the inverse of 1, 2, 3, 4, inverse that says, minus 1, equals minus 2, 1, 3 over 2, minus 1/2. And that's the way that works. So it's pretty lengthy. It's even harder for bigger matrices, like a 3 by 3 matrix would take 9 steps. But for now we have the ability to do 2 by 2 matrices. So now is an opportunity